Hello everyone, and welcome back to another GIS mathematics lecture video. And in this lecture video, I want to talk about how we can measure the length of some arc given the angle in radians and the radius of the circle that that arc belongs to. And I want to sort of derive that equation first using that definition that we have of a radius, of a radian, I should say, given a radius, and go from there. So let's go ahead and just quickly redraw our terrible circle here. Right, and we said that given some circle with some radius r, that if from the point of intersection between the radius and the circle, you go along that circle in an arc, right, that same distance r, and then you connect that up with a second radius, right? Because every single point along a circle is radius distance away from the center. That's the definition of a circle. That the angle that is made, that is subtended, right? The angle that is inside of the circle, so subtended, this arc is going to be 1 radian, right? That's how we defined a radian. But we can generalize this, right? So instead of saying 1 radian, and instead of calling this arc length r, what if we have a new circle with a radius of r? But instead of going along the circle in some length equal to the radius, what if we just went some arbitrary length, right? What if we just did this? And we call this arc length s, right? We don't know what s is. It could be any length, and this radius could be any radius. Right, and then we connect it back up again with another radius. Right. So now instead of having this be 1 radian, right, this is going to be our theta radians. Right? And so again, here, right, the reason this was 1 radian, let me sort of explicit this. Right, the reason this was 1 radian was because we had an arc length of r divided by a radius of r. And anytime you have the same thing divided by itself, you get 1. Right, but now let's go over to this sort of generic example here, and let's do the same thing. Right, in this case, we have an arc length s, right, because we don't know what it is in this case, divided by a radius r. Right, in this case, it's not going to simplify down to 1. Instead, it's going to simplify down to this theta radians. Hopefully that makes sense. Right, so now we have the ability to combine these 3 pieces of information together to solve for different things. So if we have some radius and some angle, right, we can figure out the arc length. Right, if we manipulate this equation, right, isolating arc length, right, it's going to be S equals R theta, where R is the radius of the circle, theta is the measure of the angle in radians, right? If we have the arc length and the radius, right, we can figure out theta. Right, and that's going the other way, right? We want to isolate the radius. We want to isolate radians, which we already did. Right, so this is just that equation, right? Theta equals S over R. If I scroll down a little bit, right, let's say that if instead we were given the arc length, right, and the angle, we can figure out the radius. All right, and so that would be, again, taking this equation and solving for the radius, right? That's going to be, the radius is going to be equal to multiply by r, divide by theta, right? S over theta. So hopefully that makes sense. And again, each one of these equations can be used pretty much in a plug and chug fashion. If you're given one thing, you can figure out the other. So in the next video, I want to go through an example of using these equations to figure out a different piece of the equation. Thank you.